Today's video is about using math induction to prove inequality. For number 15, 3 to the nth power greater than or equal to 3n, n greater than or equal to 1. First of all, check the statement is true for n equals 1. Since this n greater than or equal to 1, so we get started from 1. 3 to the first power greater than or equal to 3 times 1. This is true. Assume the statement is true for n equals k, which means 3 to the k's power greater than or equal to 3k. Prove the statement is true for n equals k plus 1. We want to prove for 3 to the k plus 1's power greater than or equal to 3 times k plus 1. This is 3k plus 3. So we get started from 3k plus 1. Separate first. 3k times 3 to the first power. The reason why we separate, because we can create 3 to the k's power, and we can use this inequality. So 3 to the k's power times 3 will be greater than or equal to. I change this into 3k. 3k times 3. I need to create 3k plus 3. 3k times 3, we can get 9k. For the 9k, I can write down 3k plus 6k. You want to create 3k plus 3, so I add 3, then minus 3. That equals 3k plus 3, then plus 6k minus 3. Just check 6k minus 3 is positive or negative. We know the 6k minus 3 is greater than 0. In other words, for 3k plus 3 plus 6k minus 3, it will be greater than 3k plus 3. So 3k to the k plus 1's power greater than or equal to 3k plus 3. Just remember you want to create this on the right side so that you can finish proving. Now let's go to 16. N factorial greater than 4 to the nth power. N is greater than or equal to 9. This time, we will check the statement is true for n equals 9. It's not 1 anymore. So 9 factorial equals, and 4 to the 9th power equals. So 9 factorial greater than 4 to the 9th power. Assume the statement is true for n equals k, which means k factorial greater than 4 to the k's power. Prove the statement is true for n equals k plus 1. We want to prove k plus 1 factorial greater than 4 to the k plus 1's power. For k plus 1 factorial, we can write down k factorial times k plus 1. We want to use this assumption. You have to create k factorial here. It's greater than 4 to the k's power times k plus 1. We want to create 4 to the k plus 1's power. Remember, here's the rule. A to the k's power plus a minus 1 times a to the k's power equals, we take a to the k's power out. Then we have 1 plus a minus 1. That equals a to the k's power times a to the first power equals a to the k plus 1's power. For example, if I have 7 to the k's power plus 6 times 7 to the k's power, we can get 7 to the k plus 1's power. So how I change 4 to the k's power into 4 to the k plus 1's power? First of all, we will do this distributive property. We will get 4 to the k's power times k plus 4 to the k's power. I will add 3 times 4 to the k's power so that I can create this 4 to the k plus 1's power. Then you need to subtract 3 times 4 to the k's power. Then I will put these two together. Then these two together. We will get 4 to the k's power out, k minus 3, then plus 4 to the k plus 1's power. Because this k greater than equal to 9, so 4 to the k's power times k minus 3 is greater than 0, which means this will be greater than 4 to the k plus 1's power. So k plus 1 factorial greater than 4 to the k plus 1's power. Let's go to number 19. 3n less than 4 to the n's power. N is greater than equal to 1. Check the statement is true for n equals 1. Since this n gets started from 1, we will use here n equals 1. We have 3 times 1 equal to 3 less than 4 to the first power. This is equal to 4. So this is true. Assume the statement is true for n equals k, which means 3k less than 4 to the k's power. Prove the statement is true for n equals k plus 1. We want to prove 3 times k plus 1 less than 4 to the k plus 1's power. So we get started from 3 times k plus 1. First of all, definitely distributive property, 3k plus 3. We will use this assumption, less than 4 to the k's power plus 3. We want to create 4 to the k plus 1's power. Remember, for 4 to the k's power, I add 3 times 4 to the k's power. That equals 4 to the k plus 1's power. So we will use 4 to the k's power plus 3 times 4 to the k's power. Then minus 3 times 4 to the k's power. Then plus 3. These two, we create 4 to the k plus 1's power. Then here, we will take 3 out, minus 3, 4 to the k's power minus 1. Because negative 3 times 4 to the k's power minus 1 less than 0. So this expressions is less than 4 to the k plus 1's power. So 3 times k plus 1 less than 4 to the k plus 1's power. We finish proving. Let's go to 20. 2 to the n's power greater than 10n plus 7. N is greater than or equal to 10. Since this n greater than or equal to 10, check the statement is true for n equals 10, not 1. Then 2 to the 10th power equals 1024. 10 times 10 plus 7 equals 107. So 2 to the 10th power greater than 10 times 10 plus 7. Assume the statement is true for n equals k. 2 to the k's power greater than 10k plus 7. Prove the statement is true for n equals k plus 1, which means 2 to the k plus 1's power greater than 10 times k plus 1 plus 7, which means 10k plus 17. We get started from 2 to the k plus 1's power. Separate 2 to the k's power times 2. We will use this assumption. Greater than 10k plus 7, then times 2. So we do distributive property. That equals 20k plus 14. We want to create this 10k plus 17. Since I need to create this 10k plus 17, for 20k, I will write down 10k plus 10k. Then plus 17. You need to minus 17. Then we have this 14. So put this together. You will get 10k plus 17. Then I have 10k. Combine like terms minus 3. Because this k is greater than equal to 10. This is because. So 10k minus 3 greater than 0, which means 10k plus 17 plus 10k minus 3 is greater than 10k plus 17. So 2 to the k plus 1's power greater than 10k plus 17. We finish proving.